Today we're going to be training a custom TensorFlow 2.x object detector. This is going to be done with TensorFlow GPU on Windows 10. We're going to be using the newly introduced TensorFlow Object Detection API, training a custom object detector with TensorFlow 2.x versions. This is much more recent than the older TensorFlow 1.x versions from last year. I have tested this out with TensorFlow 2.0, train a model on Windows 10. Recently the TensorFlow 2.3.0 version was released, and I'm using that today. I'm going to be following my Github tutorial, which is going to be linked in the description, and I'm going to be following this TensorFlow documentation right here. Without further ado, let's get started. So I'm going to be training my pill classification model. That's going to come with my Github repository. But the first step to starting the training process is going to be installing all the prerequisites. This means installing CUDA, cuDNN, and Anaconda. To install CUDA and cuDNN, you need a NVIDIA graphics card, which has to be CUDA enabled. This means an NVIDIA GTX 650 Plus. So I have an NVIDIA GTX 1560 Super with 6 GB of DDR6 graphics memory, which should work perfectly. So I'm going to be using TensorFlow 2.3.0, which is the newest version as of now. So you can check the graphics requirements. For TensorFlow 2.3.0, for the GPU version, you need CUDA 7.6 and CUDA 10.1. What these libraries are basically a way to shift the workload from your CPU to your GPU and utilize the graphics memory and graphics power of your graphics card. So I have added the links in my Github repository, but let's just search up CUDA 10.1 install. So go to the NVIDIA developer website and install the Windows 10 version for EXE network. Download this. And for this tutorial, I will be doing everything from scratch, so don't worry about that. So follow all the instructions needed to install TensorFlow, NVIDIA CUDA version 10.1. So I'll be right back after this is done. So after you get the NVIDIA installer is finished message, you can close this and install the cuDNN version according to your TensorFlow GPU build. And I've done that already, but you can install it from my Github repository link. And then you can open this up actually. Go inside here. And we're gonna need these files, so just hit Control-C. Oh, whoops. And then we're going to want to navigate to wherever our CUDA installation is located. So for me, it's usually program files, NVIDIA GPU Computing Toolkit, CUDA, version 10.1, and then paste whatever we had here. So we extract this here. Then after we have extracted all the files necessary, we can install Anaconda. I've already done so, so I'll just open up an Anaconda prompt. But if you haven't already, install Anaconda from the link provided in my Github repository. And once you've done this, navigate to the Anaconda navigator actually, and then just open up an Anaconda prompt. And when we're here, we're going to want to create a virtual environment to store all our packages. So I'm going to use this command right here, kind of create -n TensorFlow pip python equals 3.8. Yes. So after we create our virtual environment, we can activate it with this command, conda activate TensorFlow. But note that whenever you open up a new Anaconda terminal, you're not going to be in the virtual environment. So if you open up a new prompt, make sure to use the command conda activate TensorFlow to activate the virtual environment. But now that our virtual environment is set up, we can install TensorFlow GPU. Since we have both CUDA and cuDNN, all we have to do is use pip install TensorFlow GPU. If you don't have a NVIDIA graphics card that's CUDA enabled, you can use TensorFlow CPU instead by just using pip install TensorFlow. This should install the newest version, which is TensorFlow 2.3.0. But keep in mind that if you're using TensorFlow CPU, your training times are going to be a little bit worse, even though it's going to be doing the same exact thing. TensorFlow GPU is quite significantly better and significantly faster than TensorFlow CPU. So I might as well close up the CUDA libraries. So I'll be right back when TensorFlow GPU is finished installing. After TensorFlow GPU finishes installing, you can test out our installation by using Python, then import TensorFlow as TF. And this might take a while because the first time we're going to be importing TensorFlow. And it should successfully open this dynamic library, which is just CUDA basically. And now when it's finished importing, we can use print tf.__version parentheses. And then you should get whatever TensorFlow version you installed. So for me, that's version 2.3.0. You can exit the Python script or shell script with exit. And once we're done with this, we have to prepare our Workspace Anaconda virtual environment directory structure. So let's create a file or a folder directly in C and name it TensorFlow. So inside Windows C, you can create this file wherever you want, but I'm going to be using C because it's easier to align with the commands that I provide later on. So once you've done this, use this command cd/TensorFlow. And then we're going to git clone the TensorFlow models repository, which is right here. And this has the certain directory structure we need for training, and quite a few files that we need. So you can do this with git clone, or you can just manually download and extract the zip file. And I'm going to be using git clone, so it's a bit easier. And this might take a while, so I'm going to be right back when this is finished. After the repository is finished cloning, you're going to want to clone my repository by downloading the zip file here. And once this is done, open it up with whatever you're going to use to extract the files. I'm using WinRAR because I have it. And go into TensorFlow and extract these two files, Workspace and scripts. Once you're done with that, your directory structure should look something like this. TensorFlow models, and inside that, there's going to be Community, Official, Orbit, and Research. This is right here. Then there should be the Scripts folder and Workspace. We should have Training Demo inside. So then we're going to want to install the prerequisites. So first let's install Protobuf with Conda install -c Anaconda Protobuf. Yes, it works. Yes. And then we can cd it into the model/research directory with cd model/research. Once we're in here, we have to compile the protos with this command right here. Again, the GitHub repository is going to be linked below, so if you need to copy any of these commands, you can just do so. And then after we've done this, we have to close the terminal and open up a new Anaconda prompt. So do that, Anaconda. And let's activate our virtual environment again with conda activate TensorFlow. Whoops. Then let's install PyCoco tools. It's a dependency for the Object Detection API. So to install it with Windows support, just use these commands. Control-C, install Cython. Then once that's done, pip install that GitHub repository. And know that if you don't have Visual C++ 2015 build tools, the instruction might fail, or the installation might fail. So you can download it from this link, which is in my Github Repository. So then go back to our model/research directory with this command. And then we have to copy a setup script from object detection/packages/cpu/setup. And use that. It's override, so yes. And then this is going to install all the prerequisites needed. So Control-C, Control-V. If anything fails here, there's probably going to be an issue. There's probably an issue with PyCoco tools, meaning your installation has failed. But if everything went according to plan, you can test it out with this script, which you're going to do after this is finished. So instead of making you guys wait, I'm going to be right back when this is all finished up. I'm going to ignore the warnings here, I'm just going to move on. But now that everything is finished, we can test out our installation with this script right here. Control-C, Control-V. And then if everything goes according to plan, you should get a similar output, something like this. So let's see if everything works. It does recognize my GPU, which is a GeForce GTX 660 Super. And it appears to be testing out different models. And there we go. We get the perfect output, which is the same as right here. Ran 20 tests in 53 seconds and skipped one. Now that we've set up the Anaconda directory structure and TensorFlow Object Detection API, we can now collect and label our dataset. So with my tool detection model, I'm going to be just using my dataset from earlier. It is going to be located in Workspace/training/demo/images. I'm going to have train images and test images. They're right here. And then I'm going to use label image to label them. So I provided the label image install in my Github repository, but I'm going to just open it up right now and show you how it works. So with label image, you can create XML documents showing the labels of your images. So let's just set the open directory to right here, TensorFlow. And here you can see I have labeled all my images previously. So here we have the acetaminophen 25 milligram oral tablet. And I also have ibuprofen 200 milligrams oral tablets. And I've already labeled them earlier, so if you're using my classification model, you can just use these. But here you go, you can see that it's already given the XML documents and the images. And all the images are labeled already. So let's close this up. And after you've labeled your own images, you have to partition them into your test set and your training set. So ideally, you'd want at least 100 images for each class. I did skip a few of them because it's not too accurate, and it's just an example. But I have about 60 images in my test directory, 60 images in my train directory, and about 10 images in my test directory. So you're going to want to use about 20% of your images in the images/test folder, which is right here. And you're going to want to use the other 80% in your train directory, which is right here. So after you've labeled your dataset, you have to generate training data. So first we're going to prepare our label map, which is located in training demo / annotations / label map underscore or .db text. So here we have the label map. So we're gonna want to add a similar structure for each item. So you're using a basketball, baseball, and football detector. You're gonna want to use 3 of these items with IDs 1, 2, and 3, and the names of each of your labels. Since I'm using just the ibuprofen and acetaminophen labels, I'm going to create 2 items, one with ID 1, one with ID 2. And I'm going to copy the name from label image to label map.pb text. And then once you're done with this, just save it. I'm not going to make any changes because I'm going to be training my pill classification model. And then you should be done with your label map. After this is ready, you should be ready to train your create your training records. So first we're going to want to install pandas, which is a prerequisite for this. You can do that with install pandas. And then once that's done, cd to the TensorFlow script/preprocessing directory. And then once we're done with this, you can use these commands to generate the records for your test record and your train record. So I already have this, so let's run it again, just see if it works maybe. And if you get this message, that means it's successfully created. So it should be in the annotations directory. And here we have the test.record, because that's already previously downloaded. But if you're doing it from scratch, I recommend you delete the train.record and test.record and create your own. And I created the test.record as well. And now that we have all the record files and training files needed for training, we're pretty much ready. So first we're going to want to configure the training pipeline. So instead of creating my own, I'm going to be using one of the training pipelines from the pre-trained models, which is going to be using the SSD MobileNet V2 VPM Lite model. There's plenty of other models in the TensorFlow models right here. You can choose whichever you want, but I'm going to be using the SSD MobileNet V2 VPM Lite because it has a great balance between speed and performance. So I'm just going to download this real quick. And then once you're done downloading your model, open it up. Go into here. Or actually, never mind. Go into your training demo / pre-training models directory. And then extract this right here. And now your directory structure for your pre-trained models directory should look something like this. With your pre-trained model, with your pre-trained model, your checkpoint, your save model, and your pipeline.config. Then we're going to want to create our very own models directory. So go to training demo, go into models, and create a new folder. I'm going to name it my SSD underscore MobileNet underscore v2.fpm Lite. This is just going to be for later so it aligns with the commands. Then copy the pipeline.config from the pre-trained model. Copy this. Then go to our models directory, go to our very own model, and just paste the pipeline.config. Then we're going to want to make a few small changes to our pipeline.config file. So you can open this up into a text editor. So first what we're going to want to do is change the number of classes on line 3. So since I'm using just 2 classes with the acetaminophen and ibuprofen, I'm just going to set number of classes equal to 2. But if you're using the baseball, basketball, and football example from earlier, you set number of classes equal to 3. Then next change is on line 135. We're going to set the batch size equal to, we're going to change the batch size according to our memory. So I have 8 GB system memory and 6 GB of graphics memory. So I'm going to set batch size equal to 6. But if you set your batch size higher, you're going to need more memory and vice versa. So just set it to batch size equal to 6 for now because I only have a limited amount of memory. Then the next change is going to be on line 165. So we're going to set our fine-tune checkpoint to the correct path. And for me, this is this path right here. So just copy this, Control Z, or Control C, sorry. Then paste it right here. Then the next change is going to be on line 171. We're going to point our pipeline.config, or no, never mind. Here we're just going to set it as detection instead of classification. And then the next change is going to be on line 175. Here we're going to provide the path for our label map. For me, this is right here. Annotation / label map, PB text. And the next one is going to be the input path for the training.record file. For me, again, this is right here. I'm just going to copy this and paste. And then for line 185, change the label map path again to wherever our label map is. So for me, again, this is annotation / label map.pb text. Right here. And then for line 189, change the input path to our test.record file, which for me is annotation / test.record. And once we're done with this, just save it and exit. And then we're pretty much ready to train the model. I provided the training script inside the training demo directory, so we should be fine after cding. Control C, Control V. And just clear real quick. And then to start training, just run this program right here, or this command right here. Python model _main _tf2.py. Set your model directory equal to wherever your model is. For me, this is models / mySSD mobilenet _v2 _fpm lite. This is where my model is located, which is right here, where our pipeline.config is also located. And then with --pipeline _config _path, provide the path to the pipeline.config, which I mentioned earlier, is also right here. So then if you hit enter, it should start the training process if everything goes according to plan. You'll get quite a few warnings, but you can ignore them as long as they're not errors. And this might take a while to configure itself. But once we're done, we should get an output similar to this, providing our per step time and loss. Let's opening some libraries. So last time there was a small error with some versions because of Absol.py was probably a lower version than it's supposed to be. But now I've started training again and it should work properly this time after troubleshooting. And again, you're going to get a whole ton of warnings which you can just ignore as long as they're not errors. So then eventually, if everything works according to plan, you should get output similar to this, providing the per step time and the loss. So let's see if everything works. So anytime now, the first log is going to be coming in. And here we go. Here we have the first log providing our step 100 per step time and the loss. So that means you've officially started training our model. Now the amount of hours this will take is going to depend on our system, but for now we can kick back and relax. So the two statistics that this provides is the per step time and the loss again. And we're going to want to keep in mind what the loss is. So this loss is going to show how overfitted and underfitted our model is. So the ideal sweet spot for our loss is going to be around between 0.15 and 0.2. So for me, this took about 4,000 steps and about 2 hours last time. But once this loss has reached between 0.15 and 0.2, you can stop training with Control-C. But usually after each 100 steps, this should reduce. And then we're going to stop it when it's between 0.150 and 0.2. So let's actually try to monitor our training with TensorBoard, which is completely optional, but we can do it if we want. So to do this, just open up a new Anaconda prompt, and you got another log here. It's great. You can use Conda, activate TensorFlow, and then switch to the training demo directory. And then to start a TensorBoard server, we can just use this command right here. And again, it's recognizing my GPU, which is an NVIDIA GTX 1660 Super. And a similar error I got earlier before was around something like this. Type error, expected operation variable, or tensor got block for and explorer underscore main underscore v2.py. Hopefully we don't get any similar error. And here it says assets written to the model and everything's written. So let's check and see if it's exported properly. So go back to training demo, go to exported models, and here we go. We have our My MobileNet model. And here it says assets written to the model and everything's written. So let's check and see if it's exported properly. So go back to training demo, go to exported models, and here we go. We have our My MobileNet model. And our saved our saved model is going to be right here with our inference graph as a .pb file. So what I like to do is take the label map and put it inside the exported models. This just keeps all the information in one place. So go copy the label map, go to exported models, My MobileNet model, saved model, and then just paste it here. And that should work. And here we have the inference graph and the label map in the same place, which is better for organization. So now to test the model, I wrote two different scripts. One is for an image and one is for a video. I'm still working on webcam. So we can test it out by, let's see, going back to the training demo if we're already there, so we can just skip that. Or never mind, sorry. Let's just use this, Python tfod.py. It takes about usually 14 seconds to load the model and then a few seconds to perform inference. And it will open up a OpenCV window so we can view out the output. But since it is the first time running the program, there might be a little bit of a delay for loading the model. And here we go, it's downloading the model. It took around 30 seconds. And this is also another common error you get with running this program. So to solve it, just use pip install OpenCV Python. It takes about a minute or so. It looks like OpenCV also updated. The last time I used it, it was around 4.3.0. Whoops, there's some huge error. Let's try to install the earlier version, so 4.3.0, and see if it works this time. 4.0.38, sorry. Now I'll try it again. Oh, whoops, I might have run the wrong program. One right here. This is a bit unfortunate with all these updates coming around right when I'm recording, but whatever. Let's see if the other script I ran might have made some. Never mind, it's all good. And load up the model. Let's see if it wants inference. There we go. And here we have the output. So if you want to check out the video script, I have that here. Let's just use dir. And here we have tf video od.py. You can take a look at it if you want. It is a bit wonky, but it's in testing and it's doing decent. And here we provide the path to the video, and then it'll perform inference on each frame and display it with cv2.imshow. But I don't have my test video yet, so I'm not going to run that program. But there we go. Congratulations! You trained your own TensorFlow 2.x Custom Object Detector. If you find anything, feel free to share it, and I'd love to take a look at it, and others can learn from it too. And if you find any issues, just raise an issue in GitHub or write a comment down below. Thanks for watching, and until next time.